AI in precision agriculture. We've all heard the story about the ever-growing human population, 10 billion people by year whatever, and that we need to feed them all. And in order to do that, we need to increase our global food production by whatever percentage it is. I believe it's on 30, 60, 70%, something like that. For one part, I don't know where these numbers came from, and I also did a video where I broke down the math that since we now feed about 8 billion people, from which about 800 million experience food insecurity, and about 30 to 40% of global food production is going to waste, meaning it never reaches the table, it roughly translates to the fact that if we wouldn't be wasting so much food, we don't need to be increasing our yields by no percentage at all, because when we feed 7.2 billion people with 60% of our global food production, then we can feed 10 billion people with ease by not wasting any food, meaning better produce management. But don't mind my opinions. Now we get back to AI in precision agriculture. So precision ag is very important for growing more with less inputs, for example as fertilizers, less pesticides, you name it. And AI is here to enable these fertilizer savings while making sure that the yield stays constant or in the best case scenario increases. Now, how could AI achieve such a thing? For example, you have a big field, and although it's one big field, it doesn't mean that the soil there is homogeneous. So on some spots you can just sprinkle a little bit of fertilizer and see a 20% yield increase, whereas on a spot 50 meters down the road, you can dump a truckload of the same fertilizer and it wouldn't affect the yield at all because the soil simply isn't the same. And you/the farmer wouldn't have a clue, or at least it would be very hard to find out if it wasn't for smart combines that create precise yield maps for you. And thanks to these yield maps, next year when passing through these same spots where the fertilizer doesn't make a difference, you can turn your valves off while fertilizing or planting while fertilizing and save yourself some money on the fertilizer. That was a lot of fertilizer in one sentence, never mind. Now, this exact process of creating yield maps doesn't, or at least doesn't need to involve AI. However, if you would like to get a high-resolution map of your field that would let your sprayer know exactly where different pests, pathogens and diseases are, that's a different story. How it usually works is that you take images with a drone. The images have to have a very high resolution of, let's say, 2 mm per pixel, and after you scan the whole field, the imagery is processed with the help of AI and uploaded into your sprayer as a map. Of course, you have to have a sprayer with section control that allows the individual control of every single nozzle, at best, so that you can actually utilize the pest map and save pesticides on the spots where there are only healthy plants, but that's something else. So now we've heard a use case, but there are also challenges. First and foremost, there is a lack of skilled people in this field, and only to find a drone pilot with a license might be a pain in the arse. Another issue is a shortage of stable internet connection in rural areas. And the last issue are regulatory challenges with third-party companies storing the farmers' data gathered, for example, from scanning their fields with drones. Although AI isn't yet fully present in all parts of farming, as you can see, it's slowly getting there. And I believe that's a good trend because it will allow us to grow more food. But do we really need to grow more food? That question isn't for me to answer. Thanks for watching.